Let us take a look at this example problem. Calculate the total amount of heat absorbed in kilojoules when 25 grams of ice at minus 50 degrees Celsius is converted to steam at 200 degrees Celsius. The molar mass of water is given as 18 grams per mole. Specific heat of ice, water, and steam are given. The enthalpy of fusion and enthalpy of vaporization of water are also given. Let us try to visualize this question on the heating curve. We are starting with 25 grams of ice at minus 50 degrees Celsius, somewhere around here, and we need to take it to 25 grams of vapor at 200 degrees Celsius, somewhere around at this top. Let us now break this entire process into several parts. First, I am going to heat the ice from minus 50 degrees Celsius to 0 degrees Celsius. Let us call this step 1. The formula that we are going to use to calculate the heat for step 1 is Q is equal to mc delta T, where m is the mass of ice, which is given as 25 grams. C is the specific heat of ice, which is given as 2.06 joule per gram per Kelvin. And delta T is final temperature minus initial temperature. We are taking ice from minus 50 to 0 degrees Celsius. So the delta T is 50 degrees Celsius. If we plug in the values, we can calculate Q. Now we have ice at 0 degrees Celsius. Let us now convert ice at 0 degrees Celsius to water at 0 degrees Celsius. This is a phase change, and this is actually fusion of ice to water. Let us call this step 2. Now the heat required for a phase change is Q is equal to the number of moles times the enthalpy associated with that phase change, which is N times delta H fusion. Enthalpy of fusion is already given, and the number of moles can be calculated from grams of water. Now we have water at 0 degrees Celsius. Let us convert water at 0 degrees Celsius to water at 100 degrees Celsius. This is just increasing the temperature of water by heating. For this, the heat is equals to mc delta T, where m again is mass of water, which is 25 grams. C is specific heat of water, which is given as 4.18 joule per gram per Kelvin, and delta T is final temperature minus initial temperature. In this process, let's call this step 3, we took water from 0 degrees Celsius to 100 degrees Celsius. Therefore, delta T will be 100 degrees Celsius. Now we have water at 100 degrees Celsius. Let us vaporize the water at 100 degrees Celsius to vapor at 100 degrees Celsius. So this again is vaporization. Let us call this step 4. And for step 4, the Q or heat required is equals to the number of moles times delta H vaporization. Again, the enthalpy of vaporization is already given, and the number of moles can be calculated from the grams of ice. Now we have vapor at 100 degrees Celsius. Let us slowly increase its temperature from 100 degrees Celsius to 200 degrees Celsius. Let us call this step 5. Again, for step 5, heat required Q is equals to mc delta T. Again, m is mass 25 grams. C is the specific heat of vapor, which is given as 1.9 joule per gram per Kelvin, and delta T is temperature change. In this process, we are taking the water vapor from 100 degrees Celsius up to 200 degrees Celsius. That is, delta T is 100 degrees Celsius.